Okay guys, let's get this started. I have three examples for you guys on this last video review for the final that you guys will take tomorrow or Thursday. Okay, so here we go. There's only three problems to do, so it should be a quick video. Number one, a ball is thrown. The function h of t equals negative 16t squared plus 32t plus 20 models the height h in feet as a function of the time t. So h is the height in feet and t is the time in seconds after the ball is thrown. Part A, find the y-intercept of the graph and determine what it represents in the context of the situation. So the y-intercept, okay, the y-intercept, if you guys recall from Integrated 1 or even from earlier in this class, the y-intercept is always represented in this form, right? 0, comma y, where x is 0 and y is whatever the y-intercept happens to be. So in this case, in order to find the y-intercept, what I'm going to do is plug in 0 for t, because it's not x or y, it's t and h. I'm going to plug in 0 for t and see what I get for the height, okay? So plug in 0, I'm going to basically find h of 0 is what I'm doing. Negative 16 times 0 squared, which is 0, plus 32 times 0, which is going to be 0 again, plus 20. Negative 16 times 0 will cancel out. 32 times 0 will cancel out. So that's gone, that's gone. So h of 0, meaning I plug in 0 into the function h, gives me 20. So that's the y-intercept. The y-intercept is 20. Second part of the question is determine what it represents in the context of the situation. So we know the y-intercept is 20 for the graph. What does it represent for this ball that is being thrown? Okay, and you should think, okay, well, with a 0 means time equals 0 and 20 equals height, right? 0, 20 means that the time is 0 and the height is 20 is what we just found. So what does that represent? It means that at the beginning, before the ball is thrown or just as the ball is thrown at time equals 0, the height of the ball is 20. So in other words, we can say that the ball is thrown from a height of 20 feet. That is the initial height of the ball. Okay. Part B, find the vertex of the graph and determine what it represents in the context of the situation. So once again, let's find the vertex. Now, if you recall, the formula for the vertex is x equals negative b over 2a. Will give me the axis of symmetry, and then I'll plug in to find the y value. Okay. In this case, it's not x, right? It's t. So let me fix that and say it's t equals negative b over 2a. But it's the same idea. So negative b, that means negative 32, over 2 times a, which is negative 16. That's going to give me negative 32 over negative 32, which gives me 1. Okay? That is the x value, actually the t value of your vertex. Plug that in into your function and find h of 1. h of 1 is negative 16 t squared, which is 1 squared, right? I'm plugging in 1 right here. 1 squared is 1. 1 times negative 16 is just negative 16. Plus 32 times 1, which is just 32, plus 20. Negative 16 plus 32 is 16. 16 plus 20 is 36. So h of 1 is 36. So the vertex is 1, 36. And the second part of the question is determine what it represents in the context of the situation. What does that point represent? Okay, if you think of the graph of this ball being thrown, it's thrown from a particular height, which we said is in 20 feet. It's thrown from 20 feet up, and it goes this way, and then it goes towards the ground. The vertex is this point right here. So what is that point that we just found, 136? It represents the highest the maximum height that this ball reaches. Okay, the vertex is the maximum height of the ball is 36. What does the 1 represent? The 1 represents the time that it takes the ball to reach its maximum height. Okay, the maximum height and the time that it takes to reach that height. In 1 second, the ball will reach 36 feet, and that is the maximum height that it will reach. Okay, so part C it says find the x-intercepts of the graph and determine what they represent in the context of the situation. So the x-intercept means when does the ball hit the ground, right? X-intercepts, or when does it cross the x-axis. Another term we use are zeros or roots or solutions. So what I did right now already is I set it equal to 0. And then what I'm going to do with this is plug it all into the quadratic formula. Okay? And then when you plug it into the quadratic formula, I already have it started right here. It's negative 32, that's b, plus or minus the square root of 32 squared minus 4 times a, which is negative 16, times c, which is 20, all over 2 times negative 16, so negative 32. We're going to simplify the inside of the radical using a calculator in this case, so let me figure that out. And then I get 2304 for the inside of the radical. You're going to simplify that down and get two solutions. Remember, here you have plus radical 2304, which you can just punch into the calculator, and minus radical 2304. So radical 2304 is 48, so it's just negative 32 plus or minus 48 all over negative 32. At this point, I can just cancel the negatives right there with the 32. We can do that. And so we basically are going to find two solutions. 32 plus 48 divided by 32, and 32 minus 48 divided by 32. Okay, so use a calculator to find both of those. So when I do 32 plus 48, I get 80. Divided by 32, I get 2.5. When I do 32 minus 48, I get negative 0.5, which makes no sense. I am going to eliminate that answer, right? We're talking about time. Time is not going to be negative. So t equals 2.5 is our final answer. All right? And to answer the second part of the question, determine what it represents in the context of the situation. What does t equals 2.5 represent? It represents the time that it will take for the ball to reach a height of 0. Or in other words, it represents how long the ball will be in the air. It will be 2.5 seconds until it hits the ground. Okay, that's what it represents. Right, number 2, determine the number of times the graph crosses or touches, which another word for is tangent to the x-axis. Okay, so starting with A, the question is how many times does this graph cross or touch, in other words, is tangent to the x-axis. Okay, so what you're going to do for each one of these is set them equal to 0, because what it's really asking us is what are the zeros, or how many zeros does it have, how many x-intercepts, and solve each one to see how many you get. Okay, if you separate those out, you're going to get x equals 0, right, from this one. You're going to set this one equal to 0. Some of you guys can do that in your head, some of you guys cannot, but go ahead and set 2x minus 1 equals 0 and solve, and you're going to get x equals 1/2. And the final one, same thing, set it equal to 0, and you're going to get x equals negative 2/3. Do any of those have a multiplicity that is not 1? No, each one of those only happens once, so which means that their multiplicity is 1 for each one of them. So each one of these will cross, right? Each one of these zeros, the graph will cross through there. So this graph will cross 3 times, is our answer. Cross 3 times. It never will touch, right? Touches means, remember, odd crosses, even touches. If the multiplicity was even, it would be touching the x-axis, or it would be tangent to the x-axis. Okay, so this one will cross 3 times. B, same thing. Let's set it equal to 0. So we got x squared equals 0, and x plus 3 equals 0. The one on the left, x squared equals 0, basically gives me x equals 0. And the one on the right gives me x equals negative 3. Right? Now the difference here is that this only happens once. X equals 3 is only one time. But x equals 0 has a multiplicity of 2. Let me write it right there. Multiplicity of 2 because it says x squared, so there's really two x's here. X times x equals 0, which means x equals 0 and another x equals 0. So since the multiplicity of this one is 2, which is an even number, this one will touch the x-axis. It will not cross, it will just touch, okay? Which in technical terms we say it's tangent to the x-axis. So the answer to this one is it crosses once, right, this one, and it will be tangent once. It will not be tangent twice. It will be tangent once, right? So right at this point, x equals 0, it will be tangent to it at that point. Okay, let's move on to C. X squared plus 1 is simply the function, right? J of x equals x squared plus 1. So we set that equal to 0. Since it's not broken up into factors like these, right? We set both equal to 0. There's only one factor here. Don't set it up as x squared equals 0 and then 1 equals 0. That would make no sense. Okay, you're going to set it up as x squared plus 1 equals 0 and solve that. Now if I try to solve this, I'm going to subtract 1 and I'm going to get x squared equals negative 1. And then I take the square root of both sides and I'm going to get plus or minus. Every time you solve an equation by taking the square root of both sides, you got to include the plus or minus. And the square root of negative 1 is I. So plus or minus I. So to answer the question, how many times will it cross or touch the x-axis? For this one, you will say none. Never cross and never touch. Never tangent either. How do I know that? Because the solutions that I got are imaginary or complex, right? This is a complex plane. So since these numbers, plus or minus I, do not exist on my coordinate plane, this graph will never cross or touch the x-axis. So in other words, you're only looking for the real zeros, right? X equals 0 up here, x equals 1/2, x equals negative 2 over 3, and this one x equals negative 3, x equals 0. You're only looking for those. If you get imaginaries or complex, then you're going to say no, never cross, never tangent. All right, last one. Using the same tricks we've been doing, we can set this one up now. Okay, set all of the factors, 1, 2, 3, 4 different factors equal to 0 and solve. So 2x squared equals 0. That one you divide by 2 and you'll get x squared equals 0 because 0 divided by 2 is 0. Take the square root of both sides and you're going to get x equals 0. Multiplicity for that one is 2. X equals 0, multiplicity 2. Alright, next one. X minus 2 equals 0. That one we can pretty much do in our heads. That gives me x equals 2. The multiplicity is 1. When the multiplicity is 1, we don't need to write it. The next one, x plus 3 equals 0. Another one we could do in our head. And I get x equals negative 3. Multiplicity 1. And the last one, x squared plus 1 equals 0. Notice that it's basically the same as this one. Solve it by subtracting 1. I'm going to get x squared equals negative 1. Take the square root of both sides. I'm going to get x equals plus or minus I. And done. And now we need to answer the question, how many times will it cross or touch, be tangent to the x-axis? Okay. So here, let's see. At this one right here, it will be tangent, right? X equals 0, multiplicity 2, that means even. So it will touch, which actually in technical terms we say it's tangent, right? Tangent right at that point, once. Just once. It's not twice because the multiplicity is 2. It will be tangent once. It only touched the x-axis and then go back. So let me erase the non-technical term. For the next one, x equals 2. Since the multiplicity is simply 1, it will cross. For the next one, multiplicity is also 1, so it will cross again. And for the last one, these are complex, right? Imaginary numbers, so it will not touch or cross at this point. Okay, so the final answer is it will cross twice at 2 and negative 3, and it will be tangent once at 0. Right? It will cross twice, these two, and it will be tangent once, which is this one. All right, this is the last one I will do in this review. Okay, it says when p of x, the function p of x equals x cubed plus 3x squared minus 2x plus 7 is divided by x minus 3, the remainder is 55. You don't have to check that, although you could. You could go ahead and try to divide it and you'll see that the remainder is 55, but this is a fact that I'm telling you. When you divide that polynomial by x minus 3, your remainder will be 55. The question is, which of the following are true? Now this is a multiple response, so we can choose as many as we feel that are true. So first one, p of 3 equals 55. That means that when I plug in 3 into my function, I will get out 55. Is this true or not true? The answer that you should come up with is true. I don't have to do it. You could try. Plug in 3 into every single part of the function, and you'll see that you will get 55. However, I don't need to do it because the clue is in what they gave me. When I divide by x minus 3, the remainder is 55. That basically means that when I do synthetic division, I don't put -3 here, right? I put +3. And I set it up for synthetic division, 1, 3, -2, and 7. If I do that, my remainder will be 55, right? That's what the instructions are telling me, the information. But that also means that when I plug in 3, I'm going to get whatever my remainder is. That's what I get when I plug it in. Okay? So you don't actually have to do the work, but you could see that this means the same thing as this. Okay? When it's divided by x minus 3, the remainder is 55. That's the same thing as plugging in 3 and getting out 55. Okay, part B. 3 is a 0 of p of x. Now, if 3 is a 0 of p of x, that means that when I try 3 here, I should get 0 here. And I don't. I get 55. So that one is not true. C. 3 is not a 0 of p of x. Now, what do you think about that one? Well, since we said B is not true, 3 is a 0 of p of x, C must be true. And we can also look at here. When I tried 3, I got 55. So it's not a 0. Right? It should have given me 0. Part D. P of 3 is 0. Right? That's the same idea as here. When I plug in 3, I get 55. Well, this is a contradiction. If I plug in 3, how can I get 0 if I already said that when I plug in 3, I get 55? This one is not true. It's impossible. Right? Basically, C and D are the same thing, right? B and D are the same thing. 3 is a 0, means that when you plug in 3, you get 0. Neither of those are true. When you plug in 3, you get 55, not 0. E, x minus 3 is a factor of p of x. Your answer to that one should be no. That one's not true. If x minus 3 was a factor, then that means that I could divide it by x minus 3 and get no remainder. But I didn't get no remainder. I got remainder 55. So x minus 3 does not go into this perfectly. So it's not a factor. X minus 3 is not a factor of p of x. That one has to be true. Since E was false, this one's true. All right, final two, which are very much related to each other. Substituting -3 for x in p of x results in 55. Substituting -3 for x in p of x results in 55. That means if we plug in -3 right here, will we get 55? Okay, we don't know that. We know h. We know that if we substitute 3 in here, we will get 55, right? That's basically this. A and h are telling you the exact same thing. Substitute 3 into the function and you get 55. So h must be true because it's the same thing as a. But g, we don't know. Okay, in order to determine if that is true, you actually have to test it out by doing a -3 right there and seeing if you will in fact get 55. We can't say it's false. We can't say it's true. We don't know if it's true or false yet. Okay, we know about 3, but we don't know anything about -3. So let's do it. Bring down the 1. -3 times 1 is -3. 3 and -3 make 0. -3 times 0 is 0. -27 and 0 do not make 55. So no. That one will be a no. And there you go. A, C, F, and H are all true. They must be true according to the information that they gave me. Okay, and that concludes the review. Good luck on your test.